Hello, welcome to the Center of Math's Advanced Knowledge Problem of the Week. In this week's problem, we're going to be using cylindrical coordinates to find the volume of the solid between the two half cones. Z equals 2 times the square root of x squared plus y squared, and z equals 1 plus the square root of x squared plus y squared. So first what we're going to want to do is convert both of these into cylindrical coordinates. So x squared plus y squared equals r squared. So the square root of r squared is just going to be r. So let's simplify both of these. So when we're using cylindrical coordinates to find volume, our integrand is going to be 1. And we're going to be converting dv into r dz, dr, d theta. So let's go ahead and set up our limits of integration. So ds, or sorry, we're going to call the solid S. So this is S. So we have that z equals 2r and z equals 1 plus r. So we can use that to set our limits of integration for z. So here are our limits for z. If we're going to, the easiest one to find is going to be the limits for theta. So theta goes all the way around. So that's going to go from 0 to 2 pi. And then when we look at our projection of the region into the xy axis, we see it's a circle of radius 1. So we know that r is going to go from 0 to 1. So here we have all of our limits for our integration. So let's just set up the integral and then evaluate. So here's what the integral should look like before we evaluate. Z goes from 2r to 1 plus r. R goes from 0 to 1, and theta goes from 0 to 2 pi. So now all we have to do is evaluate the integral, and we'll get our final answer. So the steps for evaluating this integral aren't necessarily difficult. The main point of this problem is finding your limits of integration, which are listed right here, and setting up your integral. When you evaluate, you end up getting a volume of pi over 3. We're given unitless equations, so our answer is going to be unitless. So if you're given units in your equations, then the answer would have corresponding units. So this concludes this week's Advanced Knowledge Problem. Make sure you check us out on Facebook and Twitter, and take a look at our blog at centerofmath.org. Thank you.